case, this presentation was a partial fulfillment in the subject of cryptography for the degree of Bachelor of Science in Information Technology. The presentation title was The VIGBASH Cipher, a modified Vigenere cipher using Ceasar cipher as a key in enhancing security. What is a Vigenere cipher? The Vigenere cipher uses 26 by 26 table with the A to Z as the row, heading, and column heading. This table is usually referred to as the Vigenere table or Vigenere square. We shall use Vigenere table. The first row of this table has the 26 English letters, starting with the second row. Each row has the letters shifted to the left one position in a cyclic way. In addition to the plain text, the Vigenere cipher also requires a keyword which is repeated so that the total length is equal to that of the plain text. Vigenere cipher was not even enough to make sure that your passwords are safe. Hackers easily attack weak passwords when you're only using one cipher. In this modification, we will use the VIGBASH cipher, Vigenere cipher as the base cipher, and Ceasar cipher as the key. In this modification, there are more chances that your passwords and accounts are safe enough to crack. The objective of this study was to modify the Vigenere cipher to be more secure, enhance the security using the Ceasar cipher as a key, and implement the Vigenere cipher combined with VIGBASH cipher with the Ceasar cipher as a key for encryption and decryption. For the decryption process, the ciphertext and the key must also be equal. So the technique was from the key G and get the intersection, which is, say, that original text was unrepeated. Just continue to get the plain text. So let's go to our modification and let's tackle first the encryption process. There are two methods in encrypting in our modification. First was the VIGBASH and Ceasar cipher methods. We have the plain text Hermosa and the primary key Ethel, and the shifting key is 13. So the plain text, we reverse first our alphabets into #, and underneath was the index number. So the plain text, the conversion of the plain text into the index number was this, and as we get the index number, we will shift into 13th letter because it was the given shift by the user. So underneath was also the index number. We will also find this index number from this. So the aligned letter was our encrypted text. So it became 18 UREBZBFN. And now let's go to the second method, which was the Vigenere method. This is our primary ciphertext. So the primary ciphertext will be converted to the position number from the VIGBASH, which was the result displayed is this. So after the conversion of our partial ciphertext, we are now going to convert our key. We will convert and get the decimal value of our key to the ASCII goes to the modulus of 26. After we get that, we will now add the result of the decimal value of the partial ciphertext and our key, and the result, the decimal value was this, and to the modulus of 26. Now we can get the index number, which will converted into the two characters, and the conversion was this. Let's now go to the decryption process. It was just like the same to the encryption. So this was our ciphertext, and the primary key is Ethel, and the shifting key was also 13. So our ciphertext will be our ciphertext will be find the index number from the @bash cipher, and the index number of our ciphertext was this. So the cipher will be shifted into 13th letter because it was given from the user. So we shift the @bash cipher into 13, so it becomes like this. So after that, we will get this index number to the new conversion, which is the Q was 22, and Y is 14, and X is 15, and 17 is B, then Q is 22 again, and 11 is B, and U was 18. So the new decrypted text was this. Let's go to the decryption process, and let's go to the second method, which is the Vigenere method. As we get the decrypted text, we will again convert it to the position number from the @bash. Then the result was this. After that, we will get the key. We will get the key from the @bash and convert it to the decimal value from the ASCII. After we get the two needed, we will now subtract it. Then the result was this. The result of the subtraction will be added to 26 and to the modulus of 26. After that, the result will be an index number, and now we will convert it to get our plain text. And as we convert this index number, the result display Hermosa. Here's the source code of our VIGBASH cipher. As you can see, there is a hashtag reverse alphabet. So the @bash cipher, from the @bash cipher, we use to reverse the alphabets from Z to A. Okay, the first one was set the encryption true as default once it is not set. It will go to decryption when this parameter is set to false. So as you can see dito sa ating output, may makikita kayong please choose what to perform. Okay, the program will ask you to choose from the encrypt or decrypt. Then if you type E, then the encrypt word will set as true, then the decrypt will false. So if you enter E, it will allow you to enter a plain text. Let's go to this. The process will get every character of a plain text. Then as you type a plain text, the index number of each letters will be get, then it will encrypt. Encryption will be set as true. Then from the process of this, we will encrypt the plain text using the Ceasar formula, which was letter equals @bash x plus n modulus 6. Place to the list to return. Then result that append letter, or else the decrypt Ceasar formula. Yan, yung sinabi ko kanina po dito, kapag ang decrypt mo naman yung clinic mo, then madidecrypt yung plain text mo using Ceasar formula. Equals letter equals @bash x minus n the modulus of 26. Then the result will display. Then the key will generate to match the length of the key to the text. The condition there is if the text didn't meet the same length of the key, then it will continue as it reached the same length. For example, plain text is Ethel and the primary key is dog. Then the primary key will become DOG and DO. Okay. Yes, it shows repetition of character to match the text size. There will become no changes when it's in the same length as the user. For example, your plain text is Ethel, then the primary key is Ethel, then there will be no added character nor removed. The process here was we will use the English alphabet when encrypting the plain text. We will convert each encrypted character of plain text and key to binary and use addition. Then the process will go like this. If the plain text was not the same to the key, then it will repeat itself. Then to know what shape was used, there was a default from which -25 up to 25. Then we will convert the key, and as we convert, we will add the two. We will get the index from reverse alphabets using ASCII decimal equivalent of letters, and we will encrypt the formula for Vigenere, which was the encrypted text plus equals @bash x plus y with a modulus of 26. Then in the decryption process, they were also the same, as the plain text didn't align or doesn't have the same length with the primary key. Then characters of the primary key will be added. Then we will just repeat the process in the decryption. Then the difference was the formula. In the decryption process, there is a formula for Vigenere, which was decrypted text plus equals @bash x minus y plus 26 with a modulus of 26. So let's try to know our output. Okay, please choose what to perform. Okay, let's encrypt. Enter plain text, Hermosa. Then enter primary key, Ethel. Input numbers between -25 to 25 for shifting key. Okay, 23, enter. Then the cipher text will be PBAYTEX. And that's the program goes, which was the title of VIGBASH Cipher. VIGBASH Cipher. It was the modification of Vigenere Cipher using Ceasar Cipher. Thank you.